All right, now in this example here, they want us to find all of the zeros. Now, first things first, if I'm looking at this, the first thing I'm going to try is like factor by grouping, right? All the things that are in our toolbox. But if you investigate factor by grouping, this is not going to work. There's no way we could rearrange these terms that we can get a common factor. So factor by grouping is not going to work in this case, but it's definitely something. If I'm looking at this cubic function, that would be definitely the first thing I would try. In this case, it's not going to work. So in this case, we're going to use the possible rational zeros theorem. Okay, so what I'm going to do is find some candidates that I can start using, right? So I've got the factors of 2 and the factors of 1. So it's going to be my p's, right? So the numerators are going to be the factors of 2. So that's going to be plus or minus 1 and plus or minus 2. And then my q's are going to be the factors of the leading coefficient, which is just 1. So it's just going to be plus or minus 1. And so that means that I'm going to start with P divided by Q. My list is basically just going to be these, right? Because all I'm going to do is have this divided by this and this divided by this. And since it's just plus or minus 1, I'm just going to get my P's back. So my possible values is just going to be plus or minus 1 and plus or minus 2. Okay? So now I've got my candidates. Now, does this mean that I'm going to find one? No. It's a starting point. So the first thing I would do is use the easy ones. Now, plus or minus 1 are really easy because the cool thing with using 1 is that it just reduces to the sum of the coefficients. So if the sum of the coefficients add up to 0, then 1 is a 0. Okay? Because if you put 1 in here, all the x values just become 1, right? So if you add up all of the coefficients in the constant term and you get 0, then 1 will be a 0. So in this case, you get 1 minus 4, which is minus 3, plus 3, which is 0, but then you get 2. So right away, 1 will not work. Okay, what about negative 1? Well, negative 1 is also easy because all you're going to do is negative 1 only changes the sign of the terms that have an odd exponent on the x value, on the variable. So in this case here, this will change signs here, and this one will change signs here. So this will be negative 1 and negative 3. So if I do negative 1 minus 4, which is negative 5, minus 3, which is negative 8, plus 2, which is negative 6, does not give me 0. Okay? So therefore, negative 1 is not going to work. So that means those two are done. Okay, what about 2? Well, let's try 2. Well, again, all I'm doing is the remainder theorem, right? So all I'm going to do is evaluate this at 2, right? So if I put 2 in here, that's going to give me what? It's going to give me 8 minus what? 16, right? Plus 6 plus 2, okay? Now in this case here, just let's make sure I did this right. 8, so that's 16, 6, and 2. So in this case here, it's going to give you negative 16. So again, didn't work, doesn't work, okay? But now let's try negative 2. Okay, negative 2 is going to give me a negative 8 here, and then minus 16, and then minus 6 plus 2. Now in this case here, well, let me make sure I did this right. Yeah. Oh, hold on a second. I made a mistake. Hold on. Let me go back to plus 2. I did something wrong. I think I added wrong. So let's do 2. 2 goes 8 minus 16 plus 6 plus 2. I think okay, let's do this again. So, oh, yeah, this does give me 0. I added wrong. Sorry about that. So 8 minus 16, so that's going to be negative 8 plus 6 is negative 2 plus 2 is 0. Okay, so 2 works. Negative 2 wasn't going to work. That's why I stopped, because I knew something had to work. So negative 2 wasn't going to work, but 2 does work. All right, so 2, that means 2 is a 0. All right. Now, since 2 is a 0, now I can, okay, so if 2 is a 0, that means x minus 2 is a factor. But how do I find, again, they want me to find all the zeros. But the great thing is now I got a starting point. Now what will happen is now I can use synthetic division, find the quotient, which will be 1 degree lower, and now it'll be a quadratic, which means I can use all other tools in my toolbox to factor quadratic polynomials. So that's why this is really useful. Okay, so now I'm going to use synthetic division, so 2, and so it's going to be 1, negative 4, 3, 2. So now what I'm going to do is 1, 2, negative 2, negative 4, negative 1, negative 2, 0, right? So that should happen. Okay. Now, the polynomial, my resulting polynomial, is going to be x squared minus 2x minus 1. Now I can factor this quadratic, right? And so all I have to do is find factors of negative 1 that add to negative 2. Right? And there aren't, right? There aren't, this is not factorable using the techniques that we've discussed. So if here the factors of 1 is going to be 1 and negative 1, but 1 and negative 1 don't add up to negative 2, right? So in order to add up to negative 2, they would have to both be negative, and that you can't have that. So the fact that you have negative 1, you'd have to have opposite signs. So that won't work. So guess what? We have to use the quadratic formula. So we're going to use x equals what? Negative b over 2, or negative b, right? So it's going to be negative of negative 2 plus or minus the square root of b squared minus 4 times 1 times negative 1 all over 2 times 1. And so this is going to equal 2 plus or minus the square root of, this is going to be 4 yeah, so it'll end up being 4 plus 4, which is 8. So we're going to get 8 over 2. So this is going to simplify to what? 1 plus or minus the square root of 2. And so now we've found the zeros. So we've got, the zeros are going to be what? It's going to be 2, 1 plus or minus the square root of 2. So we got 3 zeros. Remember, plus or minus means that there's two of them here. 1 plus the square root of 2 and 1 minus the square root of 2. And then we have 2. Okay. All right, that's it.